Okay, so welcome to part 4 of module 2 for the topic of strain. So from your module, we have here sample problem number 3. According to the problem, we have here a 50 millimeter diameter rubber rod. So this is a rubber rod and is placed in a hole with a rigid lubricated wall. So rigid yung ating wall. And it is lubricated in such a way na pag pinasok natin yung ating rubber rod, madali siyang ipasok. Okay? There is no clearance between the rod and the sides of the hole. So, ibig sabihin, dikit na dikit, saktong-sakto yung butas ng hole natin or yung hole itself sa diameter ng ating rod. So determine the change in the length of the rod when we are going to apply an 8 kilonewton. So what would be the change of the rod if we are going to apply an 8 kilonewton? So we are to use the modulus of elasticity of 40 megapascals and the Poisson ratio of 0.45 and our force P, which is 8 kilonewtons. So for this problem, we cannot use yung equation natin na deformation is equivalent to PL over AE. Bakit? We cannot use this equation because we have a restraining property, parang restraining property, because there can now be elongation or there can now be contraction on the sides, which is the y and the z axis. Nare-restrain yung deformation natin. That's why we cannot use this formula. What we need to use is the equation deformation is equivalent to the strain along the x-axis times the length of the material. Okay? And in solving for the strain along the x-axis, we are going to use the generalized Hooke's law. So we have here the stress along the x-axis minus the Poisson ratio times the stress along the y-axis plus the stress along the z-axis divided by the modulus of elasticity. So dito sa equation natin, unknown natin si delta x, unknown natin si delta y, and unknown natin si delta z. We can solve for delta x with our working equation P over the cross-sectional area. Take note that our x-axis is this one. So what is our P? It is 8 kilonewtons. But take note, it is negative because it is pointing downwards. Okay? So it is pointing downwards. So we have negative 8,000 newtons divided by the cross-sectional area of pi over 4 times the diameter of 0.05 squared. So that is negative 8,000 divided by negative 4.074 times 10 raised to 6 pascals. That is Newton per meter squared. Okay? Next, we need to determine the stress along the y-axis and the stress along the z-axis. Okay? So, we have here, if we're going back to our figure, we have here some restrictions or some restraining with respect to the deformation of the material. Kasi, if you are going to push this rubber, the tendency for the rubber is to expand. But since it is a rigid body, it cannot expand. Hindi siya makakapag-expand. Therefore, the strain along the x-axis, the strain along the y-axis, and the strain along the z-axis would be equal to 0. Kasi hindi mag-move or hindi magkakaroon ng deformation along the y-axis and along the z-axis. That's why the strain is equivalent to 0. Therefore, the stress along the, let's say this is z-axis, and the stress along the y-axis is equivalent to the resisting force, which is equivalent to P. Okay? Ibig sabihin, yung stress sa y-axis at saka yung stress sa z-axis is equivalent sa P kasi yun yung contact pressure with respect to the material. Okay? So from there, the stress along the y-axis is equivalent to the stress along the z-axis, and that is equivalent to negative P. Bakit negative P? Because it is in compression. Kino-compress niya yung material natin. That's why it is negative P. Okay? So using our equation, strain is strain along y-axis. Strain along y-axis is equivalent to the stress along the y-axis minus the Poisson ratio times the stress along the x-axis plus the strain along the z-axis divided by the modulus of elasticity. But take note that the strain along the y and the z-axis is 0. Therefore, this equation is equivalent to 0. So substituting other values, 0 is equivalent to delta strain along y-axis, and that is negative P. So that is negative P minus the Poisson ratio of 0.45 times the stress along the x-axis, and that is negative 4.074 times 10 raised to 6 plus negative P divided by the modulus of elasticity, which is 40 megapascals. Okay, so input that in your calculator. We have 0 is equivalent to 3.333 times 10 raised to 6 pascals. Okay, so that is the contact pressure between y and our z. Okay, so we can now solve for our strain along x-axis. So the strain along x-axis is equivalent to the stress along the x-axis minus the Poisson ratio times the stress along the y-axis plus stress along the z-axis divided by the modulus of elasticity. So substituting the value, we have negative 4.074 times 10 raised to the 6th power minus the Poisson ratio of 0.45 times what is stress along y-axis. It is, we have negative 3.333 times 10 raised to 6 times 2. Tinimes 2 na natin because that is the same. Bakit siya negative? It is negative because it is compressing. Okay? Kino-compress niya yung material natin. Divided by the modulus of elasticity, which is 40 times 10 raised to 6. So we have here negative 4.074 times 10 raised to 6 minus 0.45 times negative 3.333 times 10 raised to 6 times 2 divided by 40 times 10 raised to 6. And that is equivalent to strain along x is negative 0.02686. Since we already have our strain, we can now use it to solve for our deformation. So the deformation is equivalent to negative 0.02686 times the original length of 300 mm. So times 300, that is negative 8.06 mm, or that is 8.06 millimeter compression. Okay? Ito yung deformation natin based on our given condition. Imagine if we used or if we neglect the restrictions of the rigid body. Sabihin natin na nineglect natin yon, and we went away with deflection is equivalent to PL over AE. So we have 8,000 times the length of 0.3 divided by the area. No, let's just have it as mm. 300 mm divided by the area of pi over 4 times the diameter of 50 squared times the modulus of elasticity, which is 40. And this is equivalent to 30.56 mm. And take note, it should be negative because it is compression. Imagine the deformation is far from 8.06 to 30.56 if we're going to compare both of them. Next, we have here problem number 4 from the module again. So reading it, two 1.7 inch thick rubber. So ito yun. Meron pa dito sa ilalim, hindi ko na lang dinowing. Just refer to your module, please. Pads are bonded to 3 steel plates. So we have 1, 2, and may isa pa, 3. To form the shear mount in figure given. Find the displacement of the middle plate when a 1,200 pounds P is applied. Consider the deformation of the rubber only. So itong rubber lang yung consider natin. Modulus of elasticity is 500 psi and the Poisson ratio is 0.48 for the rubber. Okay? So from the given equation on our module, hindi lang natin explain sa previous video, we have deformation is equivalent to tau or the shear divided by the modulus of elasticity for shear. Okay? So tau, or simply as the shear stress, is equivalent to the shear divided by the area. Shear force divided by the cross-sectional area of the contact surface. And next is we have the G. So we have G is equivalent to the modulus of elasticity divided by 2 times the quantity of 1 plus the Poisson ratio. Okay? So, first na isolve natin si tau. So, tau is equivalent to what would be the shear force. Take note, from the given, meron pa tayong isang block dito. Okay? Meron pa tayong layer dito sa baba. So, meron pa tayong rubber. Then, meron pa tayong steel plate. Okay? So, meron pa tayong isang steel plate. Okay? So, this 1,200 will be resisted by 2 rubber material. So, instead of using 1,200, we are going to use P over 2, and that is 600. So, for the shear force, it is 600. Take note that is 1,200. So, 600 ang i-resist nito. 600 din ang i-resist nitong material na to. Okay? So, that is 600 divided by the area. So, what would be the area? And that is, ito, yung contact surface natin for the shear. That is 9 inch times 5 inch. Okay? And that is equivalent to 13.333 PSI. So, meron na tayong tau. Next naman na isolve natin si G. So, G is equivalent to the modulus of elasticity, which is 500 PSI. Yun, 500 PSI. Divided by 2 times 1 plus the Poisson ratio, which is 0.48. Therefore, we have 500 divided by 2 times 1 plus 0.48. And that is 168.92 PSI. Therefore, the deformation is equivalent to tau divided by G. And that is equivalent to 13.33 PSI divided by 168.92 PSI. So we have 0.7 0.0789. Therefore, this is our shear strain. Okay? So, ang hinahanap natin is the displacement on the middle plate. So, if this is our plate, hahanapin natin yung magiging displacement niya dito. Itong displacement na yan. So, for the displacement, it is T times the strain. That is equivalent to 1.75 inch 1.75 inch times 0.0789. So, that is equivalent to 0.138 inch. 381 inch. Yung magiging displacement natin. So, yung i-move nung middle plate is 0.1381 inch. Okay? Next, we have here problem number 5. An initially rectangular element of material is deformed as shown. So, na-deform siya on this deformational shape. Though exaggerated lang siya. Calculate the normal strain along the x-axis and the strain along the y-axis. X-axis, y-axis. And the shear strain for the element. So we're going to solve for the shear strain. So for the strain along the x-axis, it is simply the elongation or the deformation along line AC with respect to the original AC. Okay, so ito. Bakit ito yung gagamitin natin? Because we are going to use this side instead of this side because this both two sides here, point B and this point moved. Compared sa point AC, ang nag-move lang sa atin is si A. So we can have our original reference sa point A. Okay? So we have 0.7 times 10 raised to negative 4 divided by line AC, and that is 0.25. And that is 0.7 times 10 raised to negative 4 divided by 0.25. So that is 2.8 times 10 raised to negative 4. Okay? So we move 2 decimals. So that is equivalent to 280 times 10 raised to negative 6. Para mas madali in millions. So raised to negative 3, raised to negative 6, raised to negative 9. So mas madali. Okay? In millions. Next, for the strain along the y-axis, it is the deformation on line AB with respect to the original distance of line AB. I repeat, bakit ito tayo nagre-reference? Bakit hindi natin ginagamit si point C and this point? For that case, both point C and this point moved. So, wala tayong original reference. Compared dito, ang nag-move lang si point B. So, we have an original reference. Therefore, the deformation is equivalent to 1.2. Okay? So that is 1.2. So, ito yun. Compared to 0.2. 10 raised to negative 4 divided by 0.2 inch. And that is equivalent to 1.2 times 10 raised to negative 4 divided by 0.2. And that is equivalent to 6. 6 times 10 raised to negative 4. Move natin ng dalawang decimal. So that is 600 times 10 raised to negative 6. So for the shear strain, it is simply the angle of rotation. So ito yung ating shear strain. Okay? Paano natin isa-solve yan? That would be strain is equivalent to the rotation angle AC. So the rotation of the angle AC, that is this one. So that is 1.8 is to 0.25. 1.8 times 10 raised to negative 4 divided by 0.25 plus. Next, we have this one. That is 1.5 is to 0.2. So 1.5 times 10 raised to negative 4 divided by 0.2. Therefore, the shear strain is equivalent to 1.47 times 10 raised to negative 3. And that is your shear strain. Okay?